All right, hey everybody, this is homework 2.8. Make sure to read carefully and explain your answers and show your work. So the graph shows the distance D traveled by two cars A and B over time. Distance is measured in miles, so this is miles here. And this is hours. Which car traveled slower? Explain how you know. So car A is traveling slower because the rate of change is less and the line is steeper. Right? Reviewing what we did a couple of days ago, if we're looking at the rate of change, we're looking at the y sub 2, or the second y value minus the first y value over the second x value minus the first x value. And so if we were to calculate, let's say we were to calculate the rate of change using these 2 points here, this is going over a span of 2 hours, so 4 minus 2 is 2. That goes in our denominator because it's the x value. The y value changes from 150, that's where we end, right here at 150, to 75. So we end up with 75 over 2, and if we look at that rate of change, that tells us how many miles per hour, right? 75 divided by 2, because we have the y value, which is our miles, over our x value, which is 2. And so this would be going 37.5 miles per hour in car A. So that car is traveling slower. We can also see that at the hour 3, they are at less miles than B. If we look at vehicle B, let's look at this part of the line for vehicle B, these 2 points here, and let's look at the rate of change there. So now we're looking at, in our numerator, 150 minus 100 over the span of 1 hour, because we have 3 minus 2, right? 1 hour span here. So we end up with 50 over 1, which is 50 miles per hour. So we can see that car B is going faster, and at 37.5 miles per hour, car A is going slower. So that's one way that we can demonstrate that or prove it. Number 2 says, here are descriptions of 4 situations in which the volume of water in a tank is a function of time. Match each description to a corresponding graph. So this is volume of water and this is time. Okay, so we're looking at an empty 20-gallon tank is filled at a constant rate for 3 minutes until it is half full. Then it is emptied at a constant rate for 3 minutes. So this would have 2 constant lines, one in which it is being filled and one in which it is being emptied. So that very nicely matches with graph 3. It's going up, stop, and then it's emptied. B, a full 10-gallon tank, okay, so we're starting at the top now, is drained for 30 seconds until it is half full, and then it is refilled. So this would match very nicely with graph 1, right? It's full, it's being emptied, it stops, and then it gets refilled again. C says a 2,000-gallon tank starts out empty. Okay, so we know it's going to be either 2 or 4 because we're starting empty, and it's filled for 5 hours slowly and then faster later. So that matches nicely with this graph right here, graph 2, because we can see we have kind of a flatter line here, and then all of a sudden it gets steeper, so it's now being filled faster. And then lastly, an empty 100-gallon tank is filled in 50 minutes. Then a dog jumps in and splashes around for 10 minutes, and the 7 gallons come out, and then the tank is refilled. So that shows this here, right? It's being filled. The dog comes in here. Some of the water gets splashed out, and then they continue to refill it. All right, so that is our graph 4. All right, number 3, Claire describes her morning at school yesterday. I entered school on the 1st floor, then walked up to the 3rd floor, stayed in my class for an hour after I had an hour-long class in the basement, and then I went back to ground level and sat outside to eat my lunch. The possible graph of her height from the ground floor is a function of time. So she enters on the 1st floor, which is at 0, right? That would be here. And then she walks up to the 3rd floor. So 1, 2, 3. She walks up to the third floor, and then she stays in the third floor for an hour. Then she has an hour-long class in the basement. So now she has to walk down to the basement, and then she's going to stay there for an hour. And then she goes back to the ground level, and she stays there and eats her lunch. So this is a possible graph just showing you her movement relative to the height of the ground and showing those points at which she stayed in a given place. Number 4, Tyler filled up his bathtub, took a bath, and then drained the tub. The function gives the depth of the water in inches t minutes after Tyler began his bath. So depth of water over time. These statements describe how the water level in the tub was changing over time. Use the statements to sketch an approximate graph of the function. All right, so b of 0 equals 0. That means we're starting with an empty tub at 0. Okay, at b of 1, it is less than at b of 7. At b of 9, it equals 11. So at 9 minutes, it equals 11. So let's go ahead and go here and mark that point there. 9 minutes. Oh, I actually did that 9 and 9. 9 minutes is going to be at 11, just above 10. Okay, and then at b of 10, it equals b of 23. So at whatever it is at 10 minutes, it is the same at 23 minutes. And b of 20 minutes is greater than b of 40 minutes. Okay, so that means towards the end it must have been draining. So we're going to go continuously up to this 11 point. And then let's say it continues a little bit more. And from there, it is going to stay the same until the 23-minute mark, approximately, right? And then it says b of 20 is greater than b of 40, so it's going to be drained, okay? And again, this is an approximate graph of the function. You could have actually made the water level stay the same for a little bit longer and then had it dip down at 40. That would also be okay. But as long as it meets these requirements here, then that is fine. All right, 2 functions are defined by these equations. Which function has a greater value when x is 3.9? So what you're doing here is, remember, we're plugging in 3.9 for x, anywhere you see an x, and you're trying to see then calculating y's, which one's greater. So all you have to do is calculate and tell me which is greater and show me your calculations. Function f is defined by this equation. Find the value of c when f of c is 20 is true. So this should, I don't know why this is like that, but that should be like that. So this means that we're replacing this with 20. The answer is 20, so 20 equals 3x minus 7, and then solving for x. Again, you can do that. I don't need to go do that for you. The key point here is that when you have the function equals a number, that number then replaces the function, the answer, okay? And that then allows you to solve for the input because it's giving you the output. All right, our last problem here. Function v gives the volume of water liters in a water cooler as a function of time, t minutes. This graph represents function v. What is the greatest water volume in the cooler? So this is just interpreting our graph, right? The greatest water volume is right here, and that is about, right, about 11 liters. Find the value or values of t that make v of t equals 4 true. So when is the volume of it 4 at t equals what? And t equals what time is our volume at 4 liters. Identify the horizontal intercept of the graph. So remember, vertical intercept is this one. Horizontal intercept is where it crosses this x-axis there. So that would be 4, 0. And what does that tell you? So you tell me this shows when what? So what is happening at that time? All right, that's all you are doing for this one. Now, I also, actually, let me give you your code word real quick. Your code word for today, since we had so much water conversation today, is agua. Agua. Practice our Spanish too. But also, let me go ahead and pull this up. your homework tonight is this, but I'm also giving you a review sheet. And this is the mid-unit review. This counts as an assessment grade, so it's really important that you do it. Please do it, okay? So here what you're doing is, I would strongly suggest you read the term and definition, read the example, okay, for tonight. For tomorrow, you can work on the actual problems, but tonight I would just make sure you read through and you understand what it is asking you and what it means and what the questions are, okay? So go through this. I will have a video on it tomorrow so that you have a chance to practice, but I wanted to give you this tonight so that you can look ahead and practice. We will have a small quiz on Wednesday, and that's why I'm giving you this review to help you prepare for that. If you have any questions, you know how to reach me. Happy homeworking and see you tomorrow.